What does IIT explain and predict about consciousness, and how can we test the IIT predictions? So IIT explains almost, at least tries to explain almost all aspects of consciousness that we know. And we'll talk about this more in later weeks. And in particular, IIT predicts that one, loss of consciousness is related to loss of integrated information. Second, locus of consciousness corresponds to a subset of the network that maximize integrated information. And third, content of consciousness correspond to the structure of integrated information. And the second one and third one is a bit difficult, and then we're going to talk about it next week or the week after. How can we test the IIT predictions, especially the one about this loss of consciousness relates to loss of integrated information? So to test this, first we need to understand integrated information, which for short called phi. And explanation of this concept of phi is very difficult, in fact. So, and I'll try to make a relatively easy explanation in week 11 next week. But first, I'll give you intuitive understanding of what it means. And even if you understand, or if you actually understand what it is, it turns out that it's very difficult to measure. So how can we even estimate integrated information in the real brain is a big problem. And one way to approach to this question is that just focus on the approximate measure, something that, behaves or that should behave very similarly to this theoretical construct of the integrated information. And to do that, one way to do it is like to stimulate the brain directly and measure the complexity of the response that brain generates. And in particular, the idea is to use this TMS EEG paradigm. And then I'm going to explain what the transcranial magnetic stimulation, TMS, and the electroencephalography, EEG, means later. But here's the three types of the networks that I'm going to explain these two ideas. So let's go first from in the case where very simple kind of systems. So we talk always about 8 neuron systems. And here on the right side, 8 neurons are consist of the 4 pairs of the 2 neurons. And each of them are connected. And then one part of the brain is going to be stimulated. And then the most left side here is a kind of the network that is uniform. So each of the elements is connected with everywhere else. And then the central one is the one that is connected to other 3 neurons, but the pattern of the connection is so unique that you can actually identify each neuron as a sort of specific and also unique type. And then only one part of the brain is or neuron is stimulated in this situation. So the idea of this prediction about this disintegrated system, that the ones that are only locally connected but not across, then the stimulation at the neuron 1 propagates to 2 in the next time step, most likely, yes, and then it reverberates only within these 2 neurons, and then at some point it dies out. And if that's the case, then as a pattern of the neural response or EEG response wise, we should expect that something locally gets excited and then dies out, and then nothing happens for the rest of the day. Okay, the next one, when each of the neurons are connected to each other for the rest of them, uniformly in a very similar kind of strengths and so on. And that corresponds to loss of information. Information, if you remember, is a distinction, right? A differentiation. And if the state or each neuron doesn't have any kind of individuality or differences, then whatever it is excited, it's just uniform. It doesn't have some uniqueness. And in this case, one neuron excited propagates to the other, and then everybody itself is propagating to each other. And then when some kind of inhibitory mechanism or energy is used up, then it goes back to this inactive state. So that predicts this type of the activation, uniform activation. Even if you stimulate only one part of that, it propagates to everywhere, and then everybody gets excited and then dies out at the same time. So that's a loss of information situation. Finally, this integrated information situation is the one that each of the element is connected with each other in a specific and unique way, and so that none of them is really similar to each other. If that happens, the neuron 1 stimulation propagates to only 2 and 5, 3 and 5, and then that sustains activity in a alternating manner, and then propagates over a long time and so on, and that is predicted to generate this kind of complex pattern of the response. Okay, so in summary, the idea of this stimulation and measurement kind of paradigm is that IIT predicts the loss of consciousness correlates with a lower, integrated information file, but it's very difficult to compute itself in the human brain. Therefore, one promising proxy measure is proposed, and that is to do that with stimulating the brain and measuring its response complexity. And note that in all three cases, actually, if you just measure the ongoing spontaneous activity, it may be the case that each of them has a very specific and complicated kind of patterns as well. So unless you stimulate, it may not be possible to reveal this type of the uniqueness, informativeness, and the integration and so on. So that's the sort of the idea of this stimulation paradigm. Okay, and then measure its response to the stimulation. And then in the next video, I'm going to introduce or explain what are the results of this type of experiment.